Hello, good day. Are you ready for another science experiment? Well, I am, so let's do this. Let's go. So today we are gonna learn the three types of material deformation. So material deformation, I would like to explain it as like when you add a constraint or you add an external force towards an object, what will be the effect? What will be the deformity that will be an effect of the constraint? So we actually have three types of material deformations. So first is elastic deformation. So elastic deformation it's just a temporary change or temporary deformity of an object. And usually once you remove the constraint or the force you're acting upon that object, that form of the object will go back to its original form. So elastic deformation. Next is plastic deformation. So the constraint leads to a permanent change. So permanent change when you add or act upon an object with constraint or force. Once you put a constraint there, it will permanently deform the object. But here's the tricky part. It will not break. It will just deform. And it will never go back to its original form. It will just be deformed, but it will not break. So it's plastic deformation. And lastly, fracture deformation. Basically, this is the worst type of deformation because once you put a constraint or force, external force towards an object, the object will break, like totally break, and you cannot like mend it normally. It will just break. Okay, so as a review, we have the three types of material deformations. We've got elastic, plastic, and fracture. All right, so I have some materials with me here. I'll be showing them to you. I'll be putting on some constraints to these materials and let me know what deformation is going to be the effect of the constraint. Let's start with a pencil. I'll be adding a constraint. I'll try to put deflection or bend it. Bend it, and oh no. So what's the deformation? Is it elastic, plastic, or fracture? Answer is fracture, because there's a permanent change or deformation and it actually broke. Like there's breaking that happened. So fracture. Next is, I have an eraser with me. I shall add torsion, twist, 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 or deflection, bend. And once I let go and I don't add more constraint, it goes back to its form. What do you think is the material deformation that was the effect? The answer is elastic, because it came back to its original form or figure. So nothing has changed. Next is, I have popsicle sticks with me. Just use one. I will add a constraint. I'll try to deflect. Or how about I put more deflection? Oh no, what happened? It broke to two pieces. Can I mend it again normally? No. So the material deformation is correct, fracture. Well, you're getting better and better at this. I'm so proud of you. Next is a piece of Ziploc snack bag. What if I add a constraint of tension? Oh no. It turned into two pieces. There was, or there is, what's this deformation? Fracture. Can I put it together? No. Alright, next is, I actually cut this out of plastic grocery bag, and I'm putting in compression. Compression. Is it going back to its original form, or are there humps and bumps? It doesn't go back to its original form. It's not smooth anymore, meaning the deformation, the material deformation is plastic. All right, and I've got colorful balloons. I'll use the yellow one. I'll pull it, constraint. Does it go back to its form when I release it? Meaning it's elastic. All right, so thank you so much for watching, and I hope you have learned with us or with me today about the 3 types of material deformations. Have a good day.